Hello everyone, welcome back to mychemcorner. So in today's video we are going to do revision on name reactions. Alright, we're going to do a little bit of revision, a little bit of brush up on name reactions. Alright, so before we start, if you're new to this channel, please don't forget to hit the subscribe button and the bell icon so you receive notifications as and when I upload the video. Alright, so let's move into the video. So since second year board exams are not very far, they're quite near. It's starting tomorrow and chemistry is falling on the 14th. I think it's more important to focus on those parts of chemistry that has maximum marks, and organic chemistry falls in that category. So I thought let's start with the revision of name reactions. So I'm going to put chapter wise name reactions, and I know it's going to take a very long duration for the video. So what I would do is I'm going to make a set of name reactions chapter wise in each video. So this video is going to be focused on your haloalkanes and haloarenes. Alright, and so I'll be doing each video for each functional group. So what am I going to focus on is only name reactions, because as everyone knows, apart from the mechanism, there will be a question on name reaction from each chapter. So as I've told you in the previous video where I was stressing more on mechanisms and name reactions from organic chemistry chapters, I thought I will do just a brush through these talks. Alright. So here the first name reaction as you encounter the chapter is going to be your halogen exchange method. Alright, under the topic halogen exchange method, the first name reaction that you have is a Finkelstein reaction. Alright, so I expect that each of you watching this video is not just watching being on bed or just snacking, but I hope you all are there with the book and pen, so you can just take down notes as and when I tell you something important, or just write down this as and when I'm teaching, so it becomes easier for you, because when you write you remember something. So in this I'm going to give you, say, an example of a general equation as followed by an example for each equation. So the first one is Finkelstein reaction. Now for Finkelstein reaction, I'm just going to take any alkyl halide. Alright, I'm just going to take any alkyl halide and I'm going to treat it with sodium iodide with dry acetone. So the solvent used here is dry acetone. Alright, now in this, because one of the halogen here is iodide, for sure the X that you're using here has to be only Cl and Br. Fluorine, because of its high electronegativity, you have very limited reactions. So unless specified, you can use fluorine in your NCERT. Do not use fluorine for any other reactions. Alright, so here you have an alkyl halide and you have sodium iodide. Now in this you need to identify the positive negative center. So if you see here, the R group is bonded to a halogen. Halogens should be of a negative center, and the R group bonded to it of course has to be of a positive center. On the other hand, when you see in sodium iodide, sodium is a metal, and when you look at iodide, iodide is going to carry a negative charge. So what you're going to do is, as the topic says halogen exchange method, you exchange the halogens that are there. So iodide that was here will go to the R group, and sodium that is here will be picked up by the halogen. So I'm just going to draw this box here for you to understand and for you to easily write the product. So the sodium has picked up a halogen forming NaX. And what happened? The remaining two will start bonding. So I have R and I. So Finkelstein method is a method to produce alkyl iodides. Alright, it's specifically for it. So now let's take an example. Instead of the R group, I'm just giving you a very simple example of CH3, and instead of X, I'm taking Cl plus NaI in the presence of dry acetone. So now what I'm going to do is interchange the halogen. So Cl is going to be a negative of a negative charge. The bond will break here. It will be picked up by sodium. And what is your byproduct? You're going to get NaCl plus CH3 is going to be bonded to I to give methyl iodide. So this is an example of a Finkelstein reaction. Now when they ask you to explain a particular reaction with respect to an example, you don't really have to go into fancy naming and all of that. Very simple way you can explain so that you know that your answer is correct. Alright, so that is your first named reaction. Now let's move into the second one. Now under the second one, you're going to have, under halogen exchange method, Schwarz reaction. Alright, now Schwarz reaction, you have, say for example, I've taken Rx, same alkyl halide, plus, in this case, I'm specifically going to take a reagent that has fluorine, AgF. So possible reagents that you can use, fluorinating agents, are with silver fluoride, Hg2F2, you can take AgF, you can take COF2, you can also take SbF3. Any one you can take as your reagent. Alright. In this, again this comes in the halogen exchange method. So what are you going to do? Interchange the halogens. So here also, fluorine being one of the halogen here is going to go to R group and X will go to Ag. So I'm going to break the bond here and I'm going to form this as the byproduct, similar to the previous one. So I'll get AgX plus RF I will get. So here what am I trying to produce? This reaction is used to produce alkyl fluorides only. So in one of the halogen exchange method, Finkelstein is for alkyl iodide, Schwarz reaction is for alkyl fluorides. Now let's take an example of this. Instead of R group, I'm just going to take again CH3Cl. Alright, I'm just going to take a CH3Cl here plus AgF. Now again what will happen? The bond between CH3 and Cl will get broken in between with Ag and you will get AgCl plus the remaining thing, or the part of the molecule will start bonding, CH3F. So you're going to produce methyl fluoride from methyl chloride. Alright, so this was the second method from halogen exchange reaction. So as per our syllabus, we have only this much. We have only these as our halogen exchange reactions, just two. One is Finkelstein, the other one is Schwarz. Alright, now next one, right below that in your NCERT book, you have, sorry, this is a separate set of reaction. I'll just give it numbering so you know that this is perfect. So this is A, that's the first part, and that you have two of it. I'll name this as B, and here I'll have another one which is Sand-Meyer's reaction. Alright, now Sand-Meyer's reaction, the starting material of a Sand-Meyer's reaction is not readily available. Now what do I mean by that? So Sand-Meyer's reaction is basically benzene, diazonium salt plus Cu2X2. This is the starting material for a Sand-Meyer's reaction. But the problem is, benzene diazonium salt is not easily available, but we need to prepare it. Alright, how do we do that? So I'm going to go one step before it. So here I'm just going to do, let's start with aniline. Alright, now aniline with NaNO2 and HX, could be HCl, HBr, anything, at a particular temperature 273 to 278 Kelvin. When I have this, what will happen? The amine group that is there on benzene ring will get converted to a diazo group. It will get converted to a diazo group. So this is aniline, and this product that you have here is a diazonium salt. Alright, now this diazonium salt you can take and do a lot of reaction to replace that aromatic bond on benzene ring. Out of that, when you take this particular diazonium salt and treat it with CO2X2, what will happen is the entire diazo group will come out and a halogen will be on it. So what have I done? I've replaced the entire group there, and nitrogen N2 on this aromatic system will be liberated as N2 gas. Okay, so here I am trying to prepare chlorobenzene from a diazonium salt. So the first step here is basically called as diazotization. I'm sure for those two of you all have done your practical exams recently, and you've had a viva question explain the diazonium formation of the diazo group, or explain diazotization. This is the same thing for equation, and the second part of the equation is nothing but Sand-Meyer's reaction. So when you write your exam, it completely depends on what the question is asked. Prepare chlorobenzene from aniline, or prepare chlorobenzene from diazo group. Alright, it completely depends on the question asked. Alright, so that is the third name reaction that is there in your textbook. Alright, now after this is a lot of nucleophilic substitution reaction in your textbook, and then you have so many SN1, SN2 mechanism, then you have your stereochemistry involved in it and all of that. So after this, when you move towards the last bit of your chapter, alright, you will come across other reactions. So you have one of the reactions that you will learn altogether, and that is going to be, sorry, this is C. You will learn is Wood's reaction. Alright, now you are going to learn Wood's reaction with other set of reactions together. Alright, so you will learn Wood's reaction, then you will learn, I'll teach you the Fittig reaction. Alright, and you will also learn another variation, which is Wood's Fittig reaction. As the names are seen, they are all related to each other. Okay, it's just going to be an interchange of few groups. So I'll tell you one by one. So in a Wood's reaction, what you are going to take is one alkyl halide, alright, plus a sodium atom, plus another alkyl halide. So basically you have taken two alkyl halides, therefore you will take two sodium atoms also. This is going to happen in the presence of dry ether. Now, what will happen in this is the X of each X, here you have an X which is halogen. So halogens are negative, it has to definitely break a bond and form with sodium, which is a metal. So what will happen is this will all break here, they will all form bonds to each other. Alright, so each sodium atom will pick up each halogen, therefore it will give you 2NaX. Then what will happen, the R group of the first one and the R group of the second one will form bonds to each other. So you will now get R bonded to R, forming a hydrocarbon chain. Alright, so that is one of it. Now this one, if I'm taking an example, I can just substitute instead of the R group a CH3. Okay, so I can take both R groups as CH3, or if I want to take one of the R group as CH3, the other R group as C2H5, you can still do that. There is no restriction to it. Okay, now after this, the next equation is, instead of taking R group, I'm going to specifically take benzene ring. I can't substitute a benzene ring with an R group for sure. So I'm going to take a benzene ring. The 2 sodium will still remain the same, and I will have another benzyl halide. I'll have this in the presence of dry ether. The concept will still remain the same over here. Halogen will form bonds like this with sodium. Now when this happens, what will happen? The byproduct will remain the same. It's going to be 2NaX. Now benzene and benzene is going to form bonds with each other like this. Alright, we are going to form bonds like this, and you're going to get something called as biphenyl. This itself is a self-explanatory example of Fittig reaction. There is no really example to it. The only example that you can show is the halogen can be changed to chlorine or bromine atom, and you can put it. Alright, so Fittig reaction is where both the R groups are benzene rings. What about Woods Fittig? It's going to be a mixture of Fittig and Woods. So here what do? I'm going to take an R group as a halide, as one of the alkyl chains. So I'll just put here as CH3X. Alright, plus 2Na will remain the same. Plus I'm going to put this as X, and I'm going to bond it with benzene ring. So what happened here? The first part of the molecule here, CH3, is showing that it is following a Woods reaction. The second part of the molecule, that second molecule that you have here, has benzene ring, that is following the Fittig reaction. So here, in the presence of dry ether, the concept is same. Halogen atoms will form bonds with sodium, and you get 2NaX, and benzene ring will directly bond with that CH3. Very common simple reaction that you can do is for the formation of toluene. Alright, so these 3 reactions are very much to be learned side by side. Otherwise, you might end up getting confused as to how the reactions are taking place. Alright, so in the Woods reaction, both your R groups are alkyl chains. In the Fittig reaction, both your R groups are going to be benzene ring. And in the Woods Fittig reaction, one R group is benzene ring, the other R group is alkyl chain. Alright, so you have only these many name reactions. If you open your Bosco's book and expert and all, you will find the existing reactions for which you are learning as preparation of alcohols. They will also have like Gru's process, Darjan's process and all. But for our NCERT, we don't learn those as name reactions. Alright, so these are the name reactions that you have. 6 name reactions, which includes even the 2 from halogen exchange method. Please go through this and ensure you know these name reactions thoroughly. In the next video, I will be putting name reactions from alcohols, phenols and ether. Alright, so stay tuned and thank you so much for watching.